Hi everybody, welcome back to the videos. I'm sure that you've missed them. This is Unit 4, and this unit is on the periodic table. So a lot of kids get the misconception that we're going to have to memorize all the symbols and names of elements on the periodic table. Oh no, that's not really what it's about, which at first is a big relief, right? You're like, whew, thank goodness. But what we have to know about the periodic table is more about its intricate arrangement and where it's placed on the periodic table, what that tells us about a particular element. So we'll have to know trends, like what happens as you go down the periodic table or across the periodic table, and be able to explain those trends. So that's sort of where we're headed in this unit. The first thing we want to talk about is how the periodic table is arranged. Whoops. So on these notes too, I'm not going to write everything you have to write. On some pages there will be word banks, and as I speak you will have to fill in the words to the blanks on that page, because I think that some of you are not listening to me. Are you listening to me? All right, so first of all, periodic law states that elements are periodic functions of their atomic number. Which what that means, because that's kind of a hard sentence to decipher, is what that means is when we list the elements from top to bottom according to atomic number, 1, 2, 3, 4, we hit the properties of elements tend to repeat themselves. Like for example, hydrogen 1, helium 2, lithium 3. Oh, lithium makes the same formula when it's with oxygen as hydrogen does. It's Li2O. So because of that, we put lithium underneath hydrogen because some of the chemical properties were similar. And we keep listing them. When we found things that had repetitive properties, we placed them in the same column as others that had those properties. So what we notice is when we list the elements from atomic number 1 to atomic number 116, the properties of elements tend to repeat themselves, and they tend to repeat themselves in a predictable, systematic way. And that's what we call periodic law, okay? All right, I'm not going to write on this page. Down here, whoops, let me go back up. I don't know if I can rescale this right now. Okay, again, I'm not going to write anything on this page, so you're going to have to listen very carefully. The words that you will need to fill in the blanks on this page are right down here in your word bank, okay? So as I speak, as I give you the information, you're going to find the proper word and put it in the blanks. Pretty straightforward. So the way that the periodic table is arranged is in order of increasing atomic number. It did not used to be that way. It used to be that the periodic table was arranged in order of increasing atomic mass. So from lightest to heaviest. And in most places that's true, but there are a couple places where it's not in order of increasing atomic mass. So for tomorrow, on a sheet of paper, I want you to tell me at least one location on the periodic table where it's not arranged in order of increasing atomic mass. It goes in order now of increasing atomic number, okay? If I asked you to tell me where an element lived, where an element was located, you could indicate what vertical up and down column it was in, or what horizontal row it was in. So vertical goes up and down, those are columns. Horizontal goes side to side, that's rows, like rows at a movie theater. Vertical columns are also known as groups or families. So the first column is group 1, the second column group 2, etc., down the line. So those are your up and down columns. Groups or families. And some of those groups or columns have specific names, okay? Like, for example, if we go back to that first page, everybody in group 1, which is this group here, the blue guys, not hydrogen. Hydrogen's there, but it's not part of that family. But everybody in group 1, this is your group 1 here, they have a name, and those are called the alkali metals. Group 1 is known as the alkali metals, okay? Group 2, which is right here, those are known as your alkaline earth metals. Alkaline earth metals. So alkali metals has one word before metals, group 1. Alkaline earth has 2 words before metals, group 2. All the low groups right here, 3 through 11, in some textbooks 3 through 12. Okay, that's your 3 through 11 or sometimes 12, depending on what textbook you look at. Those are the weirdos, and we call those transition metals. Okay, those are known as transition metals. This group here, which is group 17, those are the halogens. Halogens. And finally, this last group here, group 18, those are your noble gases. Okay? So let's get back on that word bank page and make sure that you can fill those in. Where'd that word bank page go? There. Okay? So group 1, alkaline metals, group 2, alkaline earth, 3 through 11, transition metals, 17 are the halogens, and 18 are the noble gases. We want to talk about what everybody in the same group has in common. There's a reason we put them in the same group. And if you look at group 1, it's pretty obvious to see, and I know we've talked about this before. Elements are placed in the same group if they have the same number of valence electrons. Remember, valence electrons are the electrons in the outer shell. If they do have the same valence electrons and they are placed in the same group, they will have, and I want to cross out the same because it's not identical, but they will have similar chemical properties. For example, when Na combines with O, it has the formula Na2O. When K combines with O, it has the formula K2O. When Na combines with Cl, it has the formula NaCl. And when K combines with Cl, it has the formula KCl. So these have what we call the same oxide formula and the same chloride formula, okay? And I'm not balancing this equation, but it kind of bugs me that I'm not. We won't worry. These are not balanced equations. I just want you to see that when they combine with other elements, they combine in the same way. Because what determines how they combine is their valence electrons. And if they have the same valence electrons, they combine the same way. Okay? There are a few exceptions to this. If you notice group 18, everybody in group 18 has, these guys rather, from neon down, they all have 8 valence electrons. However, helium up here only has 2. So the question becomes, why do we place helium in group 18 and not group 2? Why doesn't it belong in group 2? And the answer to that is if you remember, the first shell of electrons is full with 2. So helium is happy because it has a full outer shell of electrons. All other outer shells are full with 8. So everybody else here is happy. Neon, argon, krypton, xenon, and radon, they're all happy. These guys are all happy too. And the whole point of making compounds and bonding is to complete your outer shell. So since helium has 2 and has a full outer shell, and neon, argon, krypton, xenon, radon have 8 and have full outer shells, these are all happy, they're all unreactive, and they don't make bonds. So helium, even though helium has 2 valence electrons, we do not put it with group 2 on the periodic table because it doesn't behave like group 2. It behaves more like group 18. It does not make bonds with other elements. Helium is unreactive. Okay, this is a page that has a word bank, and you're going to need to fill in the words in the word bank, okay? So you're going to choose from the words down here and plug them in as I say them in the word bank. I'm not going to write anything. Make sure you're listening. So the rows on the periodic table, right? Rows, which go this way, and I don't have the whole row here, but it starts there. Row 4 goes this way, right? Rows go this way. Those are known as periods. Periods, okay? So this is period 2, period 3, period 4, or in other words, row 2, row 3, row 4. Think of like stadium seating. That's what those are. If you are in the same period, if you look at their electron configuration, for example, everybody in row 5 has 5 numbers in their electron configuration. Everybody that's in the same period has the same number of occupied principal energy levels. They have the same number of rings around their nucleus. That's what principal energy levels means. It means rings around the nucleus. Okay? Another way to say this is that they all have their valence electrons in the same shell. So magnesium has its valence electrons in the 3rd shell. Sodium has its valence electrons in the 3rd shell. And the shell number is where their valence electrons are located. Everybody in row 6 has their valence electrons in shell 6. Okay? So another way to say this is that they all have their valence electrons in the same shell or same energy level. As you go across a period, as you go across the row, the number of valence electrons increases. And the properties of the elements change systematically. And we'll look at some of these properties later. Okay? So that's it for tonight, everybody. Make sure if you haven't done your Marshmallow Lab, the final due date for that is Wednesday, and we'll see you tomorrow. Have a great night. Bye-bye.